Hey there! I hope you have a really wonderful day, and I want to tell you that I'm really happy about recording this lecture. And things we are going to explore took really long time for me to understand. We are going to explore really interesting things, and we definitely going to understand what's happened behind the scene. And I can bet that you're not going to see these things even in the paid courses. So to quickly mention what we are going to talk in this lecture, basically everything about the classes in the JavaScript. We're going to explore differences between constructor function inheritance and class inheritance because they are really different from each other and there are details that we have to understand. So it's not just a syntactic sugar. We're going to explore getter setter. We will understand super method, how constructor works, and basically we are going to talk about everything that is in here. Also, we are going to understand this diagram, which will be extremely useful for us to see the big picture. So don't hurry, take a coffee, take a tea, and we're going to explore everything step by step. Please don't hurry because learning things really takes time and this is inevitable. You cannot learn things without not giving time to them. Giving time your brain is extremely important. I hope you're going to enjoy, and if you learn something from this lecture, please don't forget to support the channel. So let's get started. I just want to make a quick reminder before starting, especially in the inheritance part, you should have how prototype inheritance work behind the scene. So if you think you don't know it enough, or if you have trouble about understanding what we are going to talk about, please watch my prototype inheritance video so that you are going to understand how inheritance work behind the scene. I covered them, so I don't want to talk about it in detail also in this video. Let's get started. So let's check the notes and try to understand the big picture and why we are learning these things. Usually we just say classes just and syntactic sugar over prototype inheritance. Yes, that's true. It uses things behind the scene that is implemented in the prototype inheritance. But there are really important details that we should know about classes, and we're going to cover them inside the inheritance part. Classes are not hoisted, means you cannot access them before you declare them. My recommendation is just don't use the hoisting for these things. Try to stick with normal uses. Code inside the classes are strict mode, which is usually better so that you won't have unexpected behavior. When we call the new, it's going to execute constructor function that is inside the classes. Class methods are non-enumerable. It's really hard for me to pronounce this. So basically this means, let's say when you do for in loop or object keys or whatever, it's not going to show up, which is something good. You can accomplish this by using other if statements, but it's just not that really extremely important, at least for now. So all you have to know is that it's better. So being non-numerable is usually better. So you don't have to handle the if statements or other things. Let's understand the syntaxes. In here we just have a constructor function and let's just copy it. This is just for us to see the syntax. We just can remove this, and this is the class syntax. So when you declare this, means now we have class person like this. This is what class syntax looks like. Also, if you notice, there is no comma or semicolon. This is also the short way to see the general syntax of the classes in JavaScript. It's just like this. What I want to mention in here is that this method is available all the instances when you create from the person. This is the same. When you create an instance of this person class, all instances can have access this method. It's just similar like this. And when you look the syntax, this is really better. This is one of the reasons that we use the classes mostly. I think this is really clear, so let's move. In here we have constructor function like this, and we have a class. And we are trying to make an instance from them. But notice that this is, we say the class doesn't accept if you don't use the new keyword. Let's just save this like this. And when we copy this too also and save, as you can see, we will get the error. Why we having this error? Just try to think. Remember, this is just a function. So you can just run function by its own without using new keyword. But when you call the new keyword, it's going to make these steps. I put them in here so that in case if I forget to mention them, basically it's create an empty object and then it's connect between the prototype and with that object we create, and then it assign this keyword to that object and then it return that object basically. So at the end we have an object. If we put a new keyword, we will get object. But what I'm trying to say is that we can run just like that, right? And in this case, it's not going to return that keyword. Instead, it's going to return what? It's going to return undefined, because this is how function works. But in here, we cannot do this. This is class. You have to obey. You have to put new keyword in there. Otherwise, it's going to throw an error. And if we just do a function variable, you can see we will get undefined because it's going to be undefined. But if you want this to work, you have to put new and save. You see the error is gone. This is important between two of them because as you can see under the hood, so many things happen with the new keyword. And classes are just, I'll say, more smart or more well designed so that you can work with easily without having so much bugs or whatever. You can have control. Let's move. In here, I'm just trying to mention how we can use the classes. And these things are important to see the big picture at first. For instance, we have a function and we return the class inside, and then we extend that class. But notice we use this variable inside here. In here we can have class like this to variable, just like function expression. This is also possible in class. In here we pass class inside the function, and we can do things with that. We can work with that class we pass, we can inherit from that, and then we can work with the inherited class, and then maybe we can just return a newly created object. At the end, the user is not going to think about the details. It's just going to happen behind the scene. And then at the end, it just, let's say it's going to get super powered object. And these things are extremely powerful. It seems easy, or we tend to underestimate, but it's really powerful. Don't worry, we're going to talk about things detailed. We just try to understand how things work right now. In here, I'm mentioning about singleton. I'm not sure if this term is exist in JavaScript. I believe it exists in some other language, something like maybe Java. But for us, the important thing is to understand the concept. So we're going to focus the concept. What we're doing is that we have a class and we invoking that class. Notice that this syntax is really similar to the immediate invoke function expression. And we can pass argument, we can work inside. At the end, we will have an instance that is made by this class. And remember that instance is just one, means you cannot use again this class because you haven't stored. And this is something good. Let's say you have only one application, right? There's no way to be two applications in your single application. In this case, it's going to be only one and it's going to be unique. This is one of the examples. Let's move. In here, I'm mentioning something that called computed property in JavaScript. Remember, you have an object, let's say, and you can have the key like this in the JavaScript. And that key is going to be, in this case, variable, and it's this string. And the value is la la la. You know that song probably. By the way, you can also do this. I know it sounds crazy, right? But it's available in JavaScript. But we never want to use something like this. Don't do this. So basically now we have this key in there, so we can use it. And in class, this is also possible. You can have computed property on the getter, on the setter, on the any method, on the property if you need, means you have power. So we have this class and we have this instance, and then we run this method and it's going to be available. If we save, you are going to see that we are singing. So it's valid. Is this going to be valid? Let's see. And remember, this is going to be semicolon because this is property. And when you define the property, you have to put semicolon. Let's save. You get to use the syntax, don't worry, it's not complex. Yeah, it's going to conflict because we try to invoke that property, which is not true. What we can do, we can just quickly do this and come to and maybe y, save. Now it's going to work. Y, save. Okay, I have to do console log, save. Now we got the true value. Let's move the getter and setter. Getter and setter. What are they? Well, in programming, probably you have heard there are so many different ways to accomplish same thing. And probably always there is pros and cons about the way you implement, about the tools that you are using. And this is one of these things. What I mean that you can use getter and setter, or if you don't like it, you might don't use it. Because you can accomplish same thing with the other ways, with the normal methods. We're going to see how it works, but it's going to depend to you whether you use it or you not use it. There is a get and set keyword that we use for the getter and setter. That's why they call getter and setter. And also I'm saying that I'm not going to cover this one in details. We're just going to make an example to see what it does. Let's get started. In here we just have a normal object and we use the get and set keywords, and we have property like this. Notice that this property name and these two are different. And probably I forgot to change this one. Let's do this. Let's see this example in here. Save. Let's see laptop. As you can see, we just have this property and we have get and set. When we do laptop.os, .os, notice that we use the OS and we get the Mac. In the set, we have to pass a value, but right now we just ignoring it, I'll say, because we will cover how we use it, like we do laptop.os equal new Mac, let's say. And now, just because we used assigned, because this is how it works, when we say laptop.os, now we will get the thing that we use. I will cover this too in the class so that you get familiar, but right now we're just seeing the example, how we use it. Let's move the other one. In this example, I just want you to see the really similarity between these two. Notice we have just an object and we have just method, right? And we do get operation system and set operation system. But we just ignore this one. I just want you to see how things are similar with each other. Now let's give this to laptop 2. So remove this one and save. Now if we do laptop 2 and laptop, probably you can see the similarity, but when we do, for instance, if we do laptop.os, remember this one is the one that has getter and setter. So we did laptop.os and we get this one. But in here, if you want to access this one, we would have to laptop to just normal knowledge that we have, you know, don't have to think complex. I could type. And we are invoking the method, as you can see. I hope this is clear. Don't worry, we are going to see how it's going to invoke things and relation between these two things, blah, blah, blah. We're going to cover this inside the class. Let's move. Here, I'm just making a simple example how we can use the define property. Notice we have an object. We just pass this object, any object or any class, and we give the name that we want to invoke later, and then we just define our get and set methods. Now, if we do laptop.os, let's just check. It's going to give also log laptop.os. It's just same. If we save, and as you can see, we get the answer. Let's move. Now let's understand what's really happening behind the scene with the get and set. Let's copy this one. Actually, let's at first see the simple one. Something like this maybe. And let's do this. Save. Now, if we want to access the doc.h, we do doc.h, right? We are doing doc.h. We not invoke something, or we just accessing the property. And when we access the property, we get this one, because this is what we call. Let's say we have a method like getH, like this, and it just return this.h. We can do this, right? And we save, we do doc.h, we get the h, and we do doc.getH. We invoke the method, and we get the h. Now, let's command this one. I think this is really clear. Let's see what's happening here. Notice that it has this.h in here. Let's remove this one. And we have getter, which is getting h, set also getting h. They have to be same. You can't have different names. You have to have same name so that this class will understand they have pair to each other. You can have single get, it's not going to affect. You can do like this. If you do dog.h, you get the correct h, and if you do dog.getInH, well, you get undefined because you didn't define something like this. If we had something, normally we would do like this, and we save. Now if we do getInH, and we will get the h. The purpose of we doing this, we will come this. Let's just understand first how things work. Let's get the old version that we had, and like this. Let's make another method which will say setting set new age, and let's say new age, and it's going to say this dot age is going to be the new age that you give me. I'm giving this example because we have to make connection between each other. Let's save. Don't hurry because it's important. You're going to see something new. If I say dog.age, it will give me 1. Now I'm saying, okay, dog.setNewAge, right? I give it to 2 and I run it. Notice that this is a method that we write. It just invoked this one. And now when I say dog.age, it's going to give me 2 because we change it. But we can also change with the set. Set is the purpose of the set is to change the property. For instance, we can do getInH. I know it's terrible named by me, but just try to focus what we're doing. And now we are going to say equal to 3. And this is how setter syntax is work. When you do this, you run it, it's going to run this one. And now when we do dog.h, we get 2. Why? Well, just because we are asking this .h. But what's happened to this operator that we did? Well, notice first of all it checked some stuff, and then it does this ._h equal to value. What does this mean? Well, this means if you do dog.h, now you get the 3. And you will probably say, why is this so messy? And why we need this if it's like this? Well, I'm showing this to you because the syntax is usually like this. Let's remove this. I hope this was clear. Let's see what we can do. Let's remove this, okay? Actually, let's just keep it. And now I will do h in here and h in here. Notice that this property name is equal to this 2, and this is the point of using this getter and setter. Now let's save. Let's do dog and dog.h. Okay, we get the h, nothing fancy. Let's do dog.setNewAge. Remember, we are doing the same. And if I say get the h, well, yeah, we get the h, which is what we expect because we change it in here. And now let's do dog.h3. Now we're using this one. We're using the setter. We passed the value and we did this one. And now if I do dog.h, I get 3. Well, before we get the 2, remember? But now we are getting 3. Why? Well, this is because we have getter and setter, and we named them correctly with this property behind the scene. it's going to know that these things are connected with each other. So when you ask dog.h, even though you did like this, and remember you are returning the this dot underscore h, you can give it any name that you want. The point is that they will have knowledge between each other. This is important to understand if you are going to use the getter and setter. Also, let's explore something else that is interesting about this getter and setter so that we can understand it better. Now, I will just undo, I will just keep it this dot underscore h. Let's comment this one, we're not going to use for now. I will remove this to the h like this. I want you to predict what's going to happen. Let's save. Well, we get the error. Why are we having this error? First of all, I want you to notice that we are using this code, which is we invoke the dog class. Also pay attention that we have set h, get h, and this h. They are equal. I mean, the names are equal. The names are the same. Is this important? Well, when we save, as you can see, we get the error, but let's understand it better. So we do, and let's do. Now, when we save, we will have same error, but if you notice that we are having this log, which means we're running this. This is mean when you invoke this class, when you make a new instance of it, behind the scene, when JavaScript runs the constructor, and just because it's aware that it exists, get and set h, it exists, it's going to run immediately this set for you. And when it runs, it sees we doing this dot h to value. Well, it's not important that you can do anything like in here. You'll still get the same error, but the point is that you're doing this dot h. And this is why people use the different name so that we don't get this error. If we do this, and if we do save, well, we fix the error, but notice we, in here, we returning this one, which is not the use case. You usually do this. If you do this one, you will get different value. But before to explore this one, I want to give the first example about something else related with this topic. Let's copy this one, okay? And just do this doc2 and doc2. Just remove this one. I'm going to change this to the age, but in here we will change this names, like maybe access age, really doesn't matter, just different name than the age. Now notice we still use the this.age and this.age in here. What do you think is going to happen? Well, let's save. As you can see, we don't get the error, but don't use this thing because it's not going to behave like getter and setter that usually it is. Also, if you notice, even though we invoke this class, we create an instance, it doesn't run set run it like before. Because if it would run, we would get a conflict. We would get a memory error. But now, since this is different name than this one, the engine will not run set for you because it will treat this two like they have different purpose than this one. This is important to understand. Now, after seeing this and after understanding this, we're going to set and get, but with not the syntax, with the other one. Just pay attention. When this.h runs, if there is an h, even though if you give like this, it's going to give you error because it's run that setter. It sees it because they are same name. Even though the getter is different, it doesn't matter. It sees the h and it's run it. I hope this is clear, so I'm going to remove this one and we will work with this one. Now we understand that names are important, and also the reason that we're changing this name in here is important. Let's work with it a bit. Let's save. Now we have dog, and dog has h. What's happened? Do you see we get the error? Also, this example proves when we run this, it's only going to run this setter. It knows that get is there, but it's not initialize it. So when we do this, it's not initialize h. Right now we initialize, in here we initialize, we are accessing the h, and since this is h, it's going to pass like, hey, you are the getter, so do your job. So when it's trying to do his job, it's doing, okay, get runt and return the this.h. And since you still asking, hey, give me the h, it's again running the h. Hey, give me the h, it's still run the h. It's like endless loop. This is why when it asks for this.h, it says, okay, I'm still going to get, because this is what getter and setter is here. Getter is here because when you do the get.h, it's responsible to handle that request that you're doing. I hope this is also clear. So I just want to show you that it's like this. So we're going to do h, and now let's save and let's work. Now we have dog. Now when we do dog.h, it's going to give us 1, and it's going to say, hey, get is run, and it's 1. Okay. Also, you know what, let's put here like this and save. Now constructor run, set run, and let's do dog and dog.h. As you can see, when we do dog.h, it's this one is run, because this one is going to run whenever we create a new instance. And since they have two same name, when we try to access the dog.h, it's going to be up to this getter to answer our question. Okay, makes sense. So you might say now we doing return.this._h, right? But we haven't done anything. But remember, when we do new.dog, the constructor run and then set run. And what set does, it does this._h is equal value. But what is value? Well, value was nothing. But when it's first run, it's not going to change anything for you unless you explicitly define. This is why we get this._h is 1, just like this.h. This is also important to understand. But what I mean, let's say I'm doing 99 in here and I'm going to save. Now what's happening? Remember, this run and this.h run, and then this one is run, and then we say this._h is going to be 99 no matter what. And now I say dog. Well, you can see its underscore h is 99. Let's say like this. We are getting 99 because we're trying to access the this dot underscore h. Let's do dot underscore h. Well, it's also exists and it's 99. But you might say, hey, what's happened to h? Well, it normally should be 1. What's happened to here? Well, remember, when we run this, it's going to run only once, this one. So it's going to run once, and then since it says, okay, this dot h, and it sees that you have getter and setter, and it's going to up to getter and setter after now, because they have same name. And in getter, we just asking to get this value that we define in here, and this is why we get 99. So whenever you do dot.h, it's now running this code, and it forgets about this one since they are same name, remember. I hope this is clear, and I'll save, and I will just do again something like this to see what's happened. Now I want to do dot.h equal to, remember it was 99, and now I'm doing 55. And this syntax is how you run your setter. You're not doing something like this. It's not like that. If you want to run this setter, you have to use this syntax. It's like you assign a property. I forgot to change this to, you remember it should be dynamic. So let's save again, back.h, back.underscore. I want to mention this one. This one is also really weird if you think about it. What I'm thinking about this is that when we did this constructor run and it's h, this is also h, and it's run this, and then this dot h equal to value, but since the value is just undefined, when you first run the setter, means it's run by itself. When JavaScript sees that it's undefined, which is undefined, it just behind the scene makes this dot h, whatever this h is, which is 1. This is why when we do dot underscore h, this dot underscore h is going to be 1. I believe this works like this behind the scene, but usually you're not going to encounter something like this crazy things, but it's really good to know how it's work. Also, we can do console.log, value, just to make sure, value, and let's see, I'm logging this, I'm saving it. As you can see, it's also triggered this one. We should just comment this one so that we understand the better, just to not invoke this. Let's save. Now we have value 1 h1, which is what I was guessing, like even though you passed undefined, it's going to assume that there is a value, and that value is going to be 1 by default, whatever you pass in here, whatever you have in here, and this is why we having this. Now let's say doc.h, okay, we get 1, and we do this, we still get 1. Now I hope this is really clear to you, why we having these things, why we getting 1. Because when you think like at first, it seems it should be undefined when you do this, but it's not, because At first run, JavaScript handles it and it's going to give you 1. This is why we get the 1. I hope this is makes sense for you. So let's just do this one for the getter and let's say 44. Now we're using setter with this syntax and we did set runt and value 44 because this is what we pass, and now it's going to be 44. Now if I do log.h, remember this is going to trigger this one, and since we ask this one underscore h, it's going to give us underscore h, which is 44. And this is how it's really work. There is nothing else. You're probably going to say, well, this is enough crazy, so this is it. Also, I'm going to talk a few things how it can be useful to use getter and setter, but you have to have really good knowledge about this concept before using it. Let's move. We are still in getter and setter. In this example, we have a party class and we have people in there. And then we have a method which gets the last person in the party, let's say. And in here we have same thing, but just with the getter. The idea is that to make us what we can accomplish with these things. For instance, we could check some logics or whatever we want to do behind the scene, like, and then we can return. But we can do same thing in here, right? So the difference is, like, in here you have to do like this. You call the method. But in here you just do party.lastPerson like it's property. And this is sometimes can be useful. Let's say you have a person, first name and last name, right? Instead of party. And you wish you had just a full name. So instead of doing like person dot full name and invoke the method, you would just do person dot full name. You might think it's going to be more convenient. I think you got the idea. So again, we invoke the method to accomplish what we want to get, but in here we access just like a property, and we have anything, any logic that we can imagine, just we could able to do in here. But we doing with the get, we do our work, and then we access just like a property. This is the idea about this example. Let's move next one. This example I already covered in here in detailed. I put this here so that I don't forget to mention about details like the age, or what if we don't put the get, what if we just have a set. I mean, technically you won't do this. You can have a single get, but usually if you do setter, you also do the getter. You might just have a bunch of getter, like get the full name, get the age, get whatever you want, but don't do anything, just get me the value. So I'm just going to skip this one. I hope getter and setter is clear now. Let's move the class fields. In here we have just this simple question. In here we have class, just like this. And now let's understand what's happening here. I copied code in here and I will comment this one. Let's save. Now we have our test. Remember, whatever we define in here, when we do test.g, we will able to get it. Sometimes people get confused, they think it's going to work also like this, but they are different. They are not same. But what about this one? Let's active this one, right? We do, it seems like it's going to bind to test class, right? When you think like this. Let's see, let's save and say test, and let's do test test.t, well, we are able to get it, which means this t is going to be reside in test class prototype. Let's test this one also, test.g, while we able to access. And when we expand this one, which is test class prototype, since we haven't put any method, it's not going to show anything. But if we would add silly method like this and save, and as you can see, we have that method in there. If you really don't know how it's work, please watch the prototype inheritance. Now let's remove this one, and let's move the static field. Let's save. Now when we check the test, we don't see the mouse property in here. What's happened? And let's try to access the mouse. Well, it's undefined. It's undefined because it's static field, which means it's going to be bind to this class. The only way to access is like this. So whatever you put static, it's going to bind the class itself, not the instance. You cannot access with instance, because instance that we make gets this mouse because of prototype inheritance. When we do test dot proto equal to the test class dot prototype, it's going to be true, because this is how it works. Remember the diagram? Imagine that this is the test class we have created, and this is test class prototype, and this is the test object. So test class mouse is going to be in here. So just because it's in here, it's bind to the test class, you cannot access from here on the fly, because this is going to follow the flow chart like this. When let's say this person tries to access some property, it's going to check. If it doesn't exist, it's going to check the chain. And what is the chain? Person prototype. Does this one has the mouse? No, it doesn't. And then this person, this test class prototype, is going to ask the upper, and obviously this one also doesn't have. And then like this, it's going to finish. It's going to say, oh, we didn't find. This is why you get the undefined. It cannot go like this. It's not like that. It has flow that have to obey just like this. And this is why we are getting undefined. So the key thing is that whenever you see the static, it's going to bind the class itself. It's not same as this one, because many people get confused about this. It's not the same. Let's move to other example. Here we have class button, and we just have a method, and it says give me the value. We create an instance of this button, which is value just collect string, and then we call this setTimeout method. This method is going to let this function that we gave into to run 2 seconds later. And this function is web API function, which means as soon as JavaScript sees this function, it's going to say, okay, I cannot handle this, I will give it to web API. So web API is going to handle this one. So web API sees this and checks it has this method function and says, okay, I will run this 2 seconds later. But remember, the situation like this always caused problems. I mean, it's not the problem, but it's the thing that we have to know, have the knowledge about. Let's save and let's see what's going to print. We save and we get undefined. Means this function runs and we get undefined, but we expect this value. We expect this to be logged. This is happening because in the web API, the button clicked lose its this keyword. So since it lose its this keyword, it's going to give us undefined. There are a few ways to fix this problem, and this is really important concept about this keyword. The easiest way is just wrap into an arrow function. Now when we save, well, nothing going to happen because 2 seconds later it's run this function, but this function just doesn't do anything. So remember, you have to invoke. Let's save. And now we have the clicked, which is inside this function. When it asks this keyword, it's able to access the original this keyword that this method has. Another useful solution of this problem, let's say this solution 1 and solution 2, we would do this. Class let you to use a syntax like that. So now this click method is a method, but it's arrow function. So now when we do set timeout, let's say 1 second. Now when we save, we will get the result that we want, because this button click is going to be this entire arrow function, and arrow function will able to access its parent, this keyword, when this set timeout start to ask. Let's move the other topic. Finally, we are going to talk about inheritance. First, let's make a quick overview, and then we are going to move to the examples. In here, we have function creature and its function constructor, by convention, of course. And then, we can do prototype and we can assign function to its prototype. How inheritance work in here is that when you do this and when you create an human instance from here, this human is going to able to access these things. Let's fast see this, to be honest. And now if I do human dot, let's say human, you see everything we have here. Let's say human dot test. Well, we able to access this because we making connection. I mean, this is how it works. You call the creature, and if you have the arguments, you would do whatever argument in here. You would do x, y, z, blah blah blah. I hope you got the idea, like this. But let's make things simple, so skip this one. The key thing is that we able to access this one, and bref was true normally in creature. We override it. We override it in here. Who knows? If you do human dot bref, it's going to point to who knows. If you remove this one and save, now if we do human, well, it's going to only able to do this too. Now if you do human dot test, it's not going to work. And this is pretty much how inheritance work with the constructor functions. Now let's see with the classes. We have same example in here, creature, Homo sapien, and now when we do extend creature, the first thing that we have to know, we have to have called the super function. And this is crucial. If you don't do this, you will get error. And you have to, of course, use the extent. We are going to explore these two things in details, don't worry. I'm showing this to you to see the syntax. So now Homo sapiens will able to call this one, mean it's going to inherit whatever we have in the creature. And you can see the difference between here and this one, how it's more clear than this one. Also, there is really big difference between these two that usually people don't mention, which is this one. And we will talk about this soon. Let's move. In here we have something called new.target. Remember before when we do the class and we try to make an instance from it without using the new keyword, right? We get the error. And the idea about this one, when we do functions, remember we can run it, right? And it will give us no error. And it will just be undefined. We saw this. But we can prevent this behavior if we want. Basically, we will have the constructor function and we will do if there is no new target, means if you call this woman without putting the new keyword, it's going to give you error. It just try to mimic the class. This is the whole idea. You can accomplish this without using the new target, but this is the built-in fastest way, I would say. You could do something in it and it's a function, and then like this. Well, this syntax is wrong obviously because it's function, and now you won't bother to whether you call new or not. You're just going to say, hey, woman.init. This is another way to fix these things. Anyway, overall, this new target is a nice feature to know. It's not that bad. You might use it. So now when we do this without using the new keyword, it's going to throw you error. Let's move. Let's talk about these things quickly, and then we will see in the examples. In here, we say you cannot access this before super, means before calling super, you cannot access this. If you don't call the super, if you don't put here super, it's going to give you error. You cannot access this keyword. If you do this, you will get error, basically. Because this super does things for you behind the scene. Next one. Let's assume that child class, in this case this one, doesn't have constructor. You know, you might have some situation like this. In this situation, the key thing that you have to remember, even though you're not putting the constructor specifically, JavaScript is going to run for you behind the scene. This constructor, you won't even notice. So what I'm saying is, whenever you do something like this, that the child class doesn't have constructor, you have to know that JavaScript does this for you behind the scene. And third one, we say super.method. Let's say we have a method, something silly. And this method, if you want to use, let's say this one inside here, and since you use the extent, you can call something called super.method. I mean, in this case, it's going to be start ref. And with that, you basically calling this method inside here. And this is super powerful. Just like you do super.method, you call the parent method. So when you do the super itself, just super, it's going to call the constructor of the parent one. In this case, parent is this one. So whenever you do super, just super, in this case it has argument, so we have to pass also argument in here so that this argument is going to be known in here. So basically when we call super, it's going to run our constructor, parent constructor for us. Lastly, we say when we inherit all the static methods and props also will be inherited. Means whatever static property or static method exists on the parent, it's also going to be exist in the child one. Let's move the examples. It's going to make more sense if you really don't get anything. It's just overview, but these are really important. We have example like this, and I just copy it to here. As you can see, we do static. We have static method and static field or property. And the purpose in here, when we do class Homo sapien extend creature, this Homo sapien will able to access this statics things. So it's just not public one. If we had something, I don't know, like this, of course we would able to inherit this one too. But the key is that the static methods and properties, we also inherited them. So when we say this, as you can see, these logs work. But remember, the static is different. Let's say we do const creature and like this, I type it before. And if we do c.speak, we will get the error because this is in bind to the creature. You can do this creature.speak. It's going to work. But for the instance, it's not going to work because it's instance. The only way it's work if that method or property is on the prototype. So when you do c.myname, it's also not going to work. Same for Homo sapiens. If we had Homo sapien instance, we still don't able to access these things. What I mean, just let's say this, right? We cannot access this one. I hope this is clear. Let's move other examples. This example is really important, and we're going to dive into what's happened behind the scene. But what I'm trying to mention is that we can inherit from built-in functions. In this case, this one. This is a constructor function built-in. And we try to extend it, and we add a bunch of stuff to this child. In this case, this is the child of the array. Array has push to its prototype. So when you do array.prototype, you're going to see a bunch of stuff, and one of them is the push down below. Maybe you don't see, but it's there. Okay, so if you say array.push, it's going to show you that it exists. Let's say we have const like this and save. Now we do u.add to whatever, and let's say this. Now we run the push array method that exists in the array prototype. Means we inherited from there, and we are using things by doing super dot whatever method name is. Remember, we can do super.method name and we can invoke whatever parent method is. I hope this also makes sense, so let's move the other. Also, we are going to talk this thing in detail, what's happened behind the scene, don't worry. It's going to be really good thing that you are going to explore. Let's move. In this example, we have two classes, and Homo sapien is the child of the creature, and it's overriding this one, this property, and we have a method, and inside that method we try to invoke this one with the set timeout, remember. And now we just invoke this method. Please try to think what's going to happen. Let's see. Let's save. Well, it loses this keyword like we said before. And what I would try to mention is that arrow function doesn't have super and this keyword. So the way to fix this, let's do this and just put it inside an arrow function, and we have to invoke it. When we do this, it's going to respect this keyword, and now it's logging the correct name, which is sapien, because we invoke we run from the sapien instance. If we do this, we save, it's going to be creature, because when it sees this, it says, okay, we don't have this property that is who is calling this. Since we don't have, if we have here, we're going to log it. Let's say if we don't have in here either, then it's going to say, okay, this isn't fine. Let's move the other example. This example is extremely important. Let's see what we're doing. We have just creature again, and we have child like this. So what we have to understand, whenever we're doing the extend something like this, and we don't pass any constructor, sometimes we don't need to call the constructor. And what's happened behind the scene, JavaScript is going to run for us this constructor. But what does this mean? Like, why it's doing this? It's doing this because super does really setup for between the classes in JavaScript. In order to have connection between everything that you are inheriting, the class, the parent one, the biggest, like the on the top one, has to initialize its constructor function. Remember, like, let's say it has the stuff name or whatever. This constructor function is going to run once, no matter how. Like, when you do this, you might think it's not running this one, but behind the scene it's run this one for you, so that it can create the object, so that it can connect between these things. Again, remember, no matter what, even if you don't put the constructor, JavaScript is going to run for you behind the scene. Let's move further and try to understand things better. Let's talk about the reason why we call the super. This is the constructor function, and we run with the new keyword, and this new keyword, we know that it does bunch of stuff behind the scene, and at the end we get an object that has connection between this F prototype, so that this instance can use anything that it has in the prototype. The similar thing is in here, but a bit different. And also we're going to talk extent, which is extremely important. But now let's understand what's happened in here. We have creature, we have child again, we save. And now remember, we said if we don't call the constructor, it's going to run by itself. And it's going to run the constructor of the creature that has, because we saying new in here. The same thing happened in here. Let's do something and just comment this one. Well, it's not doing anything, but okay, now we have this. Now we have added this one, and we're going to save. Now if you notice, it says creature constructor round. It's running because behind the scene, as I said, it's when you do this new keyword needs something. So that something is going to be in here, whatever. And then it's going to able to understand the Homo sapien is the child of this one. But at the end, as I said, the parent constructor has to run. Otherwise, it's not going to work. This is how it works. This is how it makes connection between things. Let's do also this one. And we're going to save. Well, as you can see, we get the error. When you read the error, it's really obvious what's we missing in here. Remember, we said if we don't pass constructor, it's going to handle by itself. It's going to run this for you. But if you put the constructor, you have to handle manually, because program doesn't know how many arguments you're going to have, blah blah blah, or maybe some other fancy things happen behind the scene. And this is why you have to call the super, and that super is going to say, okay, I see, and it's going to run this one for you. And after it's run this, and then it's able to access this keyword. This keyword is not going to be equal from this one, but at the end, this is how it's going to understand these two different classes. And now if we save, we remove the error. Obviously, let's do something else. Let's do start h, then let's say end, just to see the lags. And then we save. As you can see, it's run this, and then super, and super went to here, it's set up things, and then it come back, and then this lag happened, and then we do whatever we want. And this is how now when we do this, we are getting this keyword from here, but this keyword from here able to understand the difference, like the connection between the parent or even the grandparent, whatever it is, if it has, and it's work like this. And this is why we have to pass the super, because super does all the setup for you in order to correctly initialize the class. I hope this is clear right now, so let's move. Let's see what's happening in this example. As you can see, we have parent and we have child. and both of them have the type property on them. And in creature we have constructor function, and it just printed this dot type. But in here we don't have constructor. Now we know that even though we don't specify the constructor in the child, it's going to run by itself, this one, behind the scene, whenever we create something. Let's see. In here we creating the creature. Let's do this and save. Well, this is clear, right? Because we just creating an instance from the creature. And since we do new, it's going to run this constructor. And this constructor is going to be this one, the property. This is why we get creature. And if we do c.type, we will get creature. This is the normal behavior. But now if I do this and we save, well, we still get creature. What's happening here? When we extend the creature in here, and since we do new, it's going to run this one, and it's going to run the constructor of the parent before assigning this thing. The first thing that it's going to do, it's going to run the constructor inside the Homo sapien behind the scene. So it's going to say, okay, I'm going to run the parent one because this is how it's work. And when it's run, it gets, okay, console log this dot type. And what is this dot type? Well, it's creature. And this is why we have creature. Remember, whenever we do new Homo sapien or new whatever, it's going to have this flow of all the time. And this is why we get creature, creature. And now, let's say we have C, right? Let's say we try to C.type, we get creature, and we do C.h.type, we get Homo sapien. Why? Because now it's finished. In here we just log, and now after it's run the parent constructor inside here when we try to invoke it, and after it's finished, it's going to say, okay, I see you have type, and which means you overriding if it exists. Now, since you override it, it's going to be relate with the Homo sapien. Because if this wouldn't be like this, the logic, I mean, you couldn't have separate property, right? It would be really meaningless thing. But now we can access the type. I hope this is clear. Please try to think about it if you don't get. And I'm going to show you one other example relate with this topic. Just going to copy paste. And now it's really similar, but you can see we don't have constructor and we just invoking it. And we have these two instances. And we have constructor, we just log in the type again. But in here we have log. In log method, inside the parent, we just try to understand what's going to log. Well, if you understand what I'm saying before, you're probably guessing what's going to happen in here. But let's just save. As you can see, the behavior is going to be same, of course, because the constructor going to run this one, blah, blah, blah. You got the idea. But after it's finished, remember this log type, we are going to able to access from the prototype chain, right? This is the whole idea. Homo sapien instance will able to access this one. And let's just, see the things. If we do c.type, we get this one, and this one, we also get this one. If we do c.logType and we run the method, well, as you can see, this keyword points to creature, and this one is like in this one, which is true. Let's do this one. Probably you guess. Well, it's going to point to Homo sapien because it's not inside or constructor or something. Let's do this also to understand things better. Remember, this is Homo sapien. It sees it, but it will not respect what you type in here, even though if you see that it's existing there. And this is why there is something like this. Parent constructor will use its own fields. So whenever parent constructor has this type or whatever, it's not going to respect to the other one, like the child one. It's going to take value from itself. What about if you do this? Save. As you can see, even though it has type in the Homo sapien, it doesn't respect it. It's going to still say it's undefined. So don't forget this rule. I hope this is clear now. So let's move. Now it's time to really deep dive about how things work. From this point, you really have to good grasp how the proto things work. So if you have really hard time to understand things I'm going to talk, please watch the prototype inheritance because I cover them in details in there. Let's start. Let's assume this is two constructor function and we try to make the connection between. How we do this? We do parent.call and we pass this. So when we create an instance from there, this instance is going to able to whatever prototype methods that the parent one has, because it's going to set up for you the proto stuff. When you do new child, it's going to set up for you the prototype chain, whatever it needs behind the scene. But what about the class? Imagine that these are the class parent, let's say grandparent, parent, and child, three class. When you call, let's say you are in child, and you want to call the grandparent method, right? How it's really happen? Like, how it's going to up and then going to up? How it's really happen? Well, let's try to make an example. Imagine we have grandparent object. I just copy paste, by the way, and we have parent and we have child. Let's just do this. Now, remember, this is how we make connection between, right? And now I'm saying by myself, okay, if this is the way that we can run the parent, remember, if we do this.proto and speak, call this, we pass this keyword, which is child, and it's going to up, and then it's going to up, and then at the end we will get whatever we want from the parent, no matter how it's up. Imagine it's 20 object that is inheriting from each other, or 20 class inheriting from each other. And these things are just connecting child to the parent and parent to the grandparent in this case. But what we want when we call the child speak, we wanna, let's say, get this one. Let's try to save and let's do child.speak. What do you think we will get? Well, we get this error. What's happening? Remember, in here we try to understand how the class inheritance work. Remember, when you call the, let's say, speak, let's say the parent doesn't have speak and only grandparent class has the speak, and when you call the from child, it's going to up and it's get the grandparent speak and it's going to log it, whatever it is. And we try to mimic it right now. But what we do in here, we did, okay, this dot proto, well, this is going to be what? It's going to be parent. And we say parent.speak.call and we pass this. What is this? It's child. And now, okay, it says, okay, you want me to run this one. And yeah, okay, I'll run this one. So it comes here. It says, what is this? Well, we pass this to be child, right? This is the whole point that we pass. So it says, okay, child.proto. What is child.proto? Well, it's parent. So it's again calling, say, hey, parent.speak.call. And what is this? Is child. It's keep running itself, like we only able to move one level up with this approach. So because of this problem, it's clear that JavaScript use another method, another way to implement that chain inside the classes. And that thing something called HomeObject. And by having this setting inside the class methods, JavaScript able to make connection between the classes methods. So when you try to run the parents or the grandparent methods, it's not getting conflict. It's able to call it correctly. Remember when we use the super.method, whatever method name is, and we invoke like this, we invoke the parent, and this is when JavaScript uses this object to call the correct method inside. And this is the only way to able to accomplish this. Also, this thing only uses with the super. Like there is no other way to this thing using in the engine. Let's understand this better. Now we have same thing, parent, grandparent, parent, child, and same concept. We just making connection between them. And remember, this is the same concept of the class. Now what we say in here, the class and object methods will have this HomeObject property, and the super is going to use it, and this is only used for the super. If you notice, we removed that fancy protocol, this whatever, because it didn't work. So now what we're doing, we try to say, okay, hey, we have child, we have parent, we have grandparent, and child does what? Does, okay, call the super speak. Who is super speak? It's parent. Okay, who is parent speak? Is this one. So what it does, it's also calling the parent speak. So what is the parent speak? It's this one. What it does, it does console log this dot first name, right? And if you notice, we have first name in here. Also, we have first name in here. Let's see what's going to happen. We save, we the child dot speak. Remember, when we did this before, we get error, but right now we get correct answer that we expect, because this child has the first name, and this keyword able to understand who is calling it. It doesn't lose, because if it would lose, there is no point. Like, you know, if we do this and save, and let's do child that, what do you think it's going to print? Let's see. Well, it's going to print parent. Why? Because in here we don't have any first name, and we call the speak, and in here when we call the hey get me the parent speak method, and we have assigned parent, and this one is going to respect the thing that it's calling. What do you think it's going to print? Well, let's see. It's going to print parent. Why? Well, remember, they have connection, which means whenever child dot first name doesn't exist, it's going to ask its parent. In this case, its parent is this one. So is this exist? Yeah, it's exist. And this is why it's print the parent. If this wouldn't be like this, if we do this, it's going to be this one. Why? Because same concept. It's going to ask, oh, do I have first name? No. Do my upper parent has? No. Do the one more? Yeah, it has, because they have chain, prototype chain right now between each other, just like the classes. And class using this concept. That's why people mostly say they are same, just syntactic sugar, but we will cover some other interesting things. And also I want to mention that this speak, if you define like this, it's not going to work. Means the home object is not going to exist on this syntax. And this is only for the plain objects method. Means if you had the class, like whatever, even though you have this syntax, the home object is going to exist. But for the plain objects, if you define your method like this, the home object will not be exist. Let's just do this and save. I think I made some mistake. Oh yeah, this one. Save. If we do child.speak, it seems to work, right? But I missed something when we do this, because in here we call the super, we save. Now this is why we say the syntax is not going to work with the plain objects. And this is why you shouldn't use like this whenever you call the super inside the plain objects, because the home object will not be created for this one. I hope this is clear. let's move the other example. In this example, we have creature and Homo sapien. Again, we make connection between them, means the Homo sapiens is the child of this one. And in here we have zombie and sub-zombie. So what we're doing in here, as you can see, we call super.speak inside the Homo sapien, right? And we just log in it in here. And when it's come here, we do speak.console log I'm zombie, and sub-zombie is inherited from here. And in here, we just copying the Homo sapien speak method, because maybe this method, let's say it's massive, it does so many things, and we don't want to write it again, we're just copying it, right? We can do this. And now let's see what's going to happen when we do sub-zombie.speak. Well, what we expect, it's going to say, okay, what is this? It's super speak, right? And what is super speak? It's zombie, because this is the child of this one. So we expect this one to be log. When we run, well, as you can see, creature is console log. Why? Well, you see these warnings. If the method uses super, avoid to copy it, because HomeObject is bounded to it. So just because HomeObject is going to exist behind the scene in this method, when you copy this, there is no way for you to change this property. You cannot change it. So since you cannot change it, when you copy it, it's going to stick whatever parent it has. In this case is creature. So when you do sub-zombie.speak, when it calls super.speak, because super behind the scene, remember, uses this one, and it's going to log the creature speak. Just know that whenever you use the super inside the method, do not copy it, because you will get unexpected behavior and you might never find that bug, and you say, what's really happening all the time? It's really hard to find. If you encounter a problem like this, you will assume that you just copy something, but it's not like that. You copying, but that copying thing is going to obey whatever it has. I hope this is clear. Let's move the other things what's happened behind the scene. Now, let's talk about the part that is extremely important. And we are going to understand what's happened behind the scene with the extent. Now, we have two constructor function. We're familiar with these things. And we have two instances. And we have, remember, connection between these two things, because we calling it like this. So if I do h dot creature, I will able to access it. Normally h is Homo sapiens instance, and it doesn't have creature in here, but since we have connection, now we have this log, we able to access it. Now it's time to talk about the diagrams. Remember, before we talk about this in details and we know how the flow is work, and in our application right now we just have a creature. Let's say this one is creature, And next to it, we have Homo sapien, which is the child of the creature. But how things are work really? We just say it's syntactic sugar, right? But now we are going to understand it's just not like that. What I mean, let's talk about this diagram. In our application right now, we have creature. We have creature property and we have Homo sapien and Homo sapien property. We say that we have connection between the Homo sapien and creature, means Homo sapien instance can have access the creature property methods or properties. Based on this diagram, let's understand some stuff. Take the picture of this one, try to understand what we're doing. In here, I will say console.log Homo sapien dot proto. Is this equal to a creature? When we save this, you're going to see that we will get the false. What does this mean? Well, Homo sapien proto should be what? Then if it's not proto, well, it should be function dot prototype, because this is how the flow work. And we save and we check the diagram. As you can see, Homo sapien proto is going to point to the prototype. It's not pointing to creature. This is extremely important. And also the creature proto is going to point to function prototype. So this means whatever function we have or function constructor, at the end it's just a function. Their proto is going to always point to this one. So array, you know, the built-in array proto also point to this one. String proto also point to this one. And this is how it works. Let's move to the code. Just to understand better, we do console.log. I wrote two code in here, and we're going to first talk about this one, and it's true. We are asking if the creature prototype points to the object prototype, which means its proto points. Is it equal to this? It says it's true. When we say Homo sapien prototype dot underscore underscore proto, is this the creature prototype? It says it's false. And this is also extremely important. Let's move to the diagram. As you can see, the creature prototype points to the object prototype, which is second one that we type, which is true. And the first one we asked if this one points to this one. Well, no, it's not. It's point to the object prototype. And remember, this is why always people say everything in JavaScript is just an object. Because any function that you create, remember these are just a function, their prototype, and all the function has the prototype, their prototype is going to always point to the object prototype. So array prototype is also going to point this one, but array itself, it's going to point to this one, just like these two, remember? So basically function itself is going to point to function prototype, the function prototype is going to point to object prototype. The flow is always like this, except something. And now we are going to talk about this. Now we cover this. Let's see these two examples, just one, and we save. We tend to think that it's happened the same thing, but actually it's completely different, I can say. I mean, it still used the underscore underscore proto, and it does connection between things, whatever you define. It's still like that, but the flow is changed now. What I mean, let's see in the diagram first. Remember, the flow was like this: function, constructor, inheritance. But now with the class, we have this flow, which means we have parent, we have child, and that child prototype, normally it was like this, right? But with extend, it's going to point to its parent prototype, which is extremely important. And also the child function, it's going to point to the parent. It's not going to like this. And this is extremely important to understand how things work. So let's check if these things are true that we say. We going to say child prototype dot proto is this one with triple equal. We save, we get true. Normally that was the false with the inheritance, normal inheritance with this one. And the other thing, let's save, we also get the true. So if you say is the child dot proto equal like that, you get the false. But remember, we said, the array should be true, right? Let's just comment this too. We said like this. So child proto is function prototype is false. Why? Because, well, you see the diagram. And we said array is just built-in function, and all the function proto is going to point to the function prototype. Well, that's true. Well, you can do object. You can do string or number or whatever you can imagine. But in here, since we used extend, it's change, it's flow. And also, if you put to like the prototype, they should point to the what? To the object prototype, right? Like this. Well, I should change this one, obviously, because it's not like that. It should be something like function or maybe number, whatever you can imagine. Remember the diagram. So this is how it works. And as I said, as I mentioned, it's different flow with when you use the extend. So when we use the extend, it creates two references. And these two references are one, this one, second, this one. Because normally it would follow the normal flow like that. I hope this is clear. Let's move the other topic. We still haven't done with the diagrams. We're going to talk about something else soon, which is this one and this one. But before we are going to cover this topic, it's going to be also really interesting. So let's get started. What is static method and properties? I know we saw these things, but let's understand them better. Before ES6, we used things like this. And in here, we assign a function to the Homo sapien prototype, which will be exist for all the instances of the Homo sapien that you create. But in here, we assigning to the class itself, and you can do this inside. And now only the Homo sapien will access this one, not the instance one. For instance, if we do const h like that, and we do this, let's comment this one because it's going to make trouble. Now we have h, and if we do speak, it's going to run this one because this is the instance and it's going to access this via the prototype chain. If you do something like this, whisper speak, it's not going to work because it's different. It's on that function itself. So the only way for you to invoke it is this one. I hope now it's clear. So let's move the ES6 class syntax. So what we have here is that this is a method that all the instances will have access, just like this one. Remember, it's on the prototype, and all the instance that we create from this class is going to able to access this one because it's going to be on the Homo sapien prototype. But as soon as you type static on something, whether it's method or prototype, it's going to be on the Homo sapien, just like this one. Same concept, but more clear in here. Also, you can do something like this, just Homo sapien dot whatever, and you can follow the same thing, just like this. But usually we never do this, we just use the static because this would break the whole point of the having class. Now I hope this is clear. Let's move. We're going to talk about the reason why we want to use the static methods or properties. For instance, in here we have the person, and in here we have static method, and we say give me the highest power the person has, and it's going to give us the highest power person. We have person 1, person 2, like that, and if we pass them into here, just like person dot highest person, p1 and p2, it's going to give us the p1 because it has more power. Also, in built-in methods, there are so many static methods that exist. For instance, array.from, it's a static method. Since we call on the array, you can see if you have something like this and try to say this, you get undefined. You can't do this because this from is static. Or array.isArray, this is also static. Let's move. This is another usage that we might use the static, and this is really powerful, I would say. Also important to know because you might use them. We have just class like this, and we pass something, and that something is object. Imagine that it's object, and we don't want to mess with what we going to pass or whatever setting is going to be. We want to handle this internally. Maybe we have massive settings and we don't want to some other person mess with these settings. In this case, we can do return new this. This is going to be jQuery. Also, you can pass jQuery, it doesn't matter. At the end, it's going to create an instance of this class for you when you do jQuery. Obviously, I do in here. And now J is we initialize an object without using the new keyword. And as you can see, we don't get any error, right? We don't have any error. And this is another useful case that we can use static. Let's move. We mentioned about this one, but I just want to quickly also talk about this. We have person, we have static property, and we can do person.age, right? It's going to give us this value. And notice we using the class itself, not instance or something. And then we can change it just like this. And if we do like that, save, see, we change it. Or you might do this without assigning at first, and then you assign in here. Let's save. You get undefined because we don't have any static method that is age. And now we doing it, and now we log it, which we get. Let's move. In here we say static methods and properties are inheritance, which means they will get inherited. We have child, we have parent, and that child, if you notice, it doesn't have this static property and it doesn't have this static speak. When we save this, now we have child, and if we do child dot, who is this? Well, you guess it, right? It's undefined because it's static. But if you do this, who is this? It's going to point to the parent because it's inheritance. It will get inherited. Okay, and also we can do child dot speak, right? And it's going to run this one because it's static. Remember, whatever you see static, it's going to bind to the parent itself, not the instance. But we can use this one, right? Since it's just in here, right? Just do child speak. Not speak, sleep. Yeah, child is sleeping. Let's do this, which means we can override the static method. Since it inherits, we can override, right? So save this and do child.speak. Now it's going to say child speaking because we overriding the parent one. Same would be this one also. If we do child save and child dot, who is this? It's going to be child because we override it. Let's move the next one. Okay, this is time to talk about the extent again. Now imagine that we have class language and we do language.create. What this mean? Well, we expect to language has the static create method or whatever it is. Let's first explore something. You know that we have built-in object, right? We can see, let's say it has object.create static function that is bind to here. Let's see what's inside the object prototype. Let's see, we have has own property function, right? Remember, this is inside object prototype. As you can see, back to our topic, when we save, in here we get language create is undefined. Well, seems this is obvious, right? But let's do language dot. Let's type something like this. When we save this, well, you can see we get this one, but in here we don't get. What's happening in here? Try to think about the diagram or the flow that you think how it's work in JavaScript. And why we getting these things? Let's explore what's happening. Remember, this is object prototype. You know, this method is exist on here, and this is exist on object itself. Let's move the diagram that I was talking about. Okay, what we did, we just create a language, and remember we said whenever we create something, it's going to point to the proto, to the function prototype, and the language prototype is going to point to the object prototype. So what we're trying to do, we did language dot create, right? And it was undefined. Well, it was undefined because the only way to JavaScript search is through the prototype chain. And when we check the language prototype chain, it's going to up, which is function prototype, and then it's going to chain and it's object prototype, and then here and it's null. This is why it doesn't find, because language create is on here. I mean the create function in here, so it doesn't access it with this flow. And you cannot change the flow on the fly. But when we did language that has own property, it still chain the prototype chain and function, and it come here, it sees in here that function is exist, and this is why we able to access it. Okay, I think this makes sense, but let me ask you something else. Let's see. In here, I have created an instance of the language, and I'm trying to do language.create, which means I'm trying to access the create method. And same in here, so I'm trying to access the has on property method. What do you think? Do you think it's going to be something different? What is going to be logged based on the things we learned? Well, let's discuss on the diagram again. Imagine that we have language object that we create is in here. So that language is proto going to be what? Going to be language prototype, right? And it's going to ask, hey, do you have create? It says, no, I don't. Let me check the upper level. It's going to ask this one. And this one also doesn't have. And it's also going to upper level. What is upper level? It's this one. So it's going to be undefined. What about the has on property? Also, if you get confused, think like this. Remember, we have instance, and instance proto is going to point to parent prototype. This is the same concept. So language proto is going to point this one, and it's going to ask this one, and it's going to find that has own property, and then it's going to log it. Let's see in the console. Now we save, and as you can see, we get undefined, and for here we get has own property. It's same, but just don't get confused, even though if you do language.prototype, sorry, I mean the upper level prototype, we still get undefined for here, because at the end when we start from here, it's going to one up level, which is language prototype, and it also doesn't have it. Now we understand this, let's start to change the flow. Okay, let's talk about this example. Even though I'm really sleepy, I still want to explain this one. Now we have language class and we extend from the object. Notice that we are extending, and we know that when we do extend, we have two different connection that we are creating. And let's see in the diagram. Remember, this one was the normal flow. And when we ask the language dot create, it goes like this to ask that create method. But since we make the connection between the object right now, means the language is going to be child of the object. So the new flow is going to be like this. Language is the child of the object right now, and the flow is changed. As you can see, it's not be like this, it's going to be like this, because this is the whole point when we do the extend. And the proto of the language, normally it was like this, and it's not changing. But if it was, let's say, you extend from the array, that language prototype would point to the array prototype, and array prototype would point to the object. Anyway, in here, the thing is that flow is changed, and when the language asking, hey, do I have create? No, I don't. So, okay, let's ask my parent. What is my parent? It's object. So, object, do I have create? Yes, I have. Okay, get me the create method. It's work like that. And now we able to access the language create. And for the other thing, language has property name or whatever. I really don't recall. And it's going to ask, hey, do I have that has own property method? No. Do this has? No. And it keeps going up. I mean, it keeps follow the chain and ask this one also doesn't have, and come here. And object prototype, do you have that method? Yes, I do. So okay, give me. So it uses from here. And now language can also use the method that is on here, whatever method that you want to access. Well, the key is that we able to access whatever property or methods in here. I believe this is clear. Let's just see in the console. In the console, we log these things, and as you can see, it's not undefined anymore. And now we understand how really things work behind the scene with the extend. You can extend array, you can extend string if you want. And all the things are going to be same concept. Let's say you did array. Now the language prototype is going to point to array prototype, and array prototype is going to point to the object prototype. And language proto is going to point array itself, and array proto is going to point function prototype. And the flow is just going to be like this. I believe this is clear, so let's move. Let's talk about private, protect, and public. What are they and why we should learn them? In JavaScript, when you define something to private, whether it's method or property doesn't matter, you can only use that information inside that class. No matter what, you cannot use it from outside or from inherited class even. So it's private to that class. This is why we call it private, right? If something is private to you, you might don't share with anyone. It's private to you. We're not going to talk about the product. Maybe in TypeScript is going to be better use case to talk about. But essentially the idea of the product, that Well, you can use inside the class, right? It's obvious. But you can also use inside the inherited classes. And the difference between these two is this one. So you can use inside the inherited classes if you have product, fields, or the method, which you can do this in TypeScript, but just we will skip this one. So the difference between these two, again, it's only that this one, inherited classes, can use the product field that you made. Public is, well, you can use inside that class you defined, and inside any inheritance, this is also used, and also any instance, which means you can use from public. And up until now, we always use this. We never used the private. It was always public because we able to access it no matter what. So let's talk about the private more. Syntax is like this. If it's method, if it was the just property, we would do like this. That's all. And you can have private static method also. You can have static property also. But you have to have this hashtag. It's important. If you don't put hashtag, it's not going to work. Also, you can have private getter and setter if you like. This is a warning that you cannot do like this. It's not going to work. So basically, don't use this syntax. The purpose of using the private is that to prevent, to expose things. This is like something you have control over your application, because the last thing that you let people use, it's going to be more clear and it's going to protect you. People will not easily change things, or the developers, what I mean. And this is essentially called encapsulation term. In here we say private won't conflict with the public. So you can have this and this at the same time. It's not going to conflict, but usually we won't recommend to do this because it's going to bring more complex to understanding things. In here, I'm just making an example about that the inherited class doesn't have access to its parent private property. We will see this, don't worry. So let's move the examples. We have an example like this, and notice this is the private method, this is normal method, and this is also normal method. Now when we do P, we see like this. You can see that we have that private function, but if I do something like this, it's not going to work. But if I do this, well, it's going to work. And now the way that we can access this one, if we want, we can do p.logboth. You might say, okay, I expose this one and I able to use it. Well, you still have control by doing this. You limiting the user that have control directly on this one. In here, maybe you just get the value, you store the value if it has value, and you work with the value inside here. But the user cannot change things that is inside here. Let's move the other example. In this example, we have parent, we have child, and inside parent we have private property, and we are able to use it inside this function, which means if I do parent.get this one, we will able to run this. And since this is inheriting from this one, we can say this. You might think that we said child cannot able to access the parent private method or property. But notice in here, we're not accessing directly. We're just invoking this method, and still this method has control. And if we try to do something like this, let's say I do test on the child, and I'm trying to do parent, this one from here. If I save, well, you can see we are having the error. It says you can only use that thing inside this class. And now what we're doing, we try to use this one inside child. This is why we're having this error. We cannot do this. So we remove, and we can do something like this, right? Also, let's say I don't want to just do this. I just want to invoke it and then do, let's say, some fancy. I'm defining my own method in here, but I'm using my parent method, any method that is going to use this maybe. And we save. If I do child.betterway, now I'm able to get this value, but notice we are having this method that helps us to use this thing. And then we have power to change things, like if we need to work with this value. So basically everything is up to us how we design. Having private methods and static methods are extremely important. Let's move. This example is similar to previous one, but let's just see what we're doing. We have student, and let's do something student dot take permission. Now what we do, we use the student instance and we invoke this thing, and inside here we have this private, which is this one. Let's talk about this one. In there we getting the take shower value from here. We calling this method inside the child, which is student, and we logging what we get, and then we change it. We change it and we store it. We work with this private property, but we doing some fancy things. We change it, maybe we pass in the function, we change it, we pass in another function, we do so many stuff with that, and then we store it, and then we get the value. If we do stu.change like this, now as you can see, we able to get this value, and that value was from here. Notice we expose in here, we work in here, we store, and we log it. And this is powerful. Let's move. In this example, we're talking about getter setter. Notice that they don't have same name, but usually what we do, we just do like this, right? But just for simplicity, I'm just making the dummy example, and I'm trying to work in here like I will invoke this one from here. So what this do? This is say, okay, do this. So what does this mean? This means that we're trying to invoke the setter, which is this one. When we do this, this is going to run this one. And then in here, we try to access. Access is doing this dot first name. It's just logging this one in this case. If we save, let's say p.do this, Now, as you can see, we get just dummy setter because it's run, because we do this. And then we log in that value, and then we log in the first name Jack. Let's move. In here, we are going to see how we can use the private property inside the constructor. In this case, whatever property you want to use, you have to declare before. If you don't do this, you will get the error. Let's try. See, we are having the error. Engine doesn't accept this. It says you have to define if you want to do like this. Because we're passing things outside, and that thing is going to be private to inside the class. So we do this, and now in here we have person like this. We don't pass last name, and in here we do this. If we lock this to just like this, we get what we expect, and these are private, remember. Let's move. Another useful case for the private can be like this. Imagine we have a person and it accepts the age parameter. Remember, this is similar to what we saw before, but before we did something like this, right? But now we have an static and it's private, and that function takes an age and let's say checks if it's bigger than 18, and then it's going to return true. Otherwise, it's going to return an error. And what we're doing in here, it's like we having validation. We saying not this. We saying, hey, check the person if that person is bigger than 18. And this is just an example. If it not, we say just put the 18. Let's do this. Const. Let's check these two examples like this. Obviously, it's going to give us error. But when we check this one, let's say person, right? As you can see, it has 23. But remember, it's private. You cannot do this. It's not going to work. But in here, we say person 2, it's not allow us to create that person 2. Well, in this case, maybe we can do something like this. It's going to make much more sense, maybe. But essentially, when we do this, it's passed in here and it runs this code. I mean, this code, this one. So this code runs and it checks the age and it's not bigger than 80, so it's run this code. This is why we get an error. We can do something like this also if we want. Save and person 2. In here we return 99, which is true value. Since it's true, it gives us the age, whatever we put. I hope this is clear, so let's move. Let's talk about InstanceOf and how it works. As you can see, we just have person instance and we're asking these questions. But how these things are works, right? When we do is person instance of this person constructor function, we should have this mindset. When the person start to look its chain, does it encounter with the person prototype? If it does, this means it's instance of that thing. But what I mean, as you can see, I put the questions like, is object prototype appears when you chain on person object, and same in this. Let's check in the diagram. Now we have person, person prototype. Now we asked, is person instance of this one, right? When we start to chain, since we're asking this one, if the person prototype is on the chain way, this means person is instance of that person constructor function, which means it will be true. And we ask about the object prototype also. I mean the object. We said is person instance of object. Well, if you go one level up and second, well, it sees this one, so yeah, it's instance of the object. That's true. And we asked for the function. Now when we say is person, if you chain, well, it doesn't encounter with this one, right? So this is why it's going to say false, mean the person is not instance of the function. Let's see in the code. As you can see, we have logs like that. True, true, false, which is false, this one. Also, you cannot do something like this. Okay, don't do this. It's not something that you can do. You get error. What about this too? We're asking, is the person instance of the function? Remember, the rule was if it's met with that thing prototype, right? So let's save. As you can see, we will see true, true. Why? Because as you can see, person is in here, and if you go one level up, it's going to see that, which is true, because we ask this one. And we ask this one, is person instance of object. If you go one level up and one more, well, it sees the object prototype, and yes, this is why it's instance of the object. This is how instance of is work behind the scene. Let's move. Let's talk about this example. As you can see, we have two constructor function and we have child instance, and I'm asking these questions to you. Try to think about them, please. Let's think together. Well, first of all, they are function constructor, and even though they inheritance means they have connect, we learned that connection between constructor function and classes are different. In here, when we say child prototype proto is parent prototype, well, no, this is not true. So it should print false. In here, we say child prototype proto, is this true? Yes, that's true, because it's going to point there. You know the diagram? In here, we say child instance of child. Well, that's true, because if we chain from this instance, it's going to match with the child prototype. This is why it's going to be true. In here, we say instance of parent, and you might think, okay, since parent is just parent of the child, well, that should be true, right? Normally we would think like this. But no, it's not going to be true, it's going to be false. Because if you follow the chain, it's not going to meet with the parent prototype. It's only going to encounter with the child prototype. If we save, you can see false, true, true, and false. Let's see in diagram. Imagine this is parent, this is child, and we have child object in here. So you can see the flow is going to be like this, right? Because we ask the child. Also, you can see how the prototype flow is just point to the object prototype. This is why we get these logs. Let's move the other example. In here, as you can see, it's really similar, but we have inheritance with the class. And I'm asking you these questions. If we check this one, this is going to be true because the child prototype is going to point to the parent prototype because this is the class inheritance. And if you can see, obviously, if this is true, this is going to be false because it's not like that, the flow. And in here we say child instance of child. Well, yeah, that's true. And we say child instance of parent. Well, this is also true. Remember, it was false before, but now it's true because this is class inheritance. Safe and true, false, true, true. Let's check the diagram. As you can see in diagram, we have parent, child, and we have child object. Imagine we have child object in here. So child prototype points to parent prototype and it's point to this one, and flow is like that. We talk about these things, and this is why we getting the log that we set. Okay guys, this is it. I hope you really enjoy it, and I hope you really learned, explored valuable things. If you do appreciate about my works, please consider to support the channel. Also, you can write comments. I will definitely do my best to respond to them. I wish you a lovely day. See you next time. Bye bye.